My name's Stephen Hillier, and it's my pleasure to introduce Stephan Kaufhold from the BGR in Hanover. I think that's pretty much like the kind of German geological survey. And he's the latest clay scientist to be interviewed in our Clay Minerals Group Jubilee Year interview series, which we decided to extend. And one of the reasons for doing that at the moment is Stephan is going to give the next George Brown lecture, kicking off the International Clay Conference, which is just about a month away or more just now. Stephan started his career, I think, in Aachen in 1993. His thesis then, I guess, like his undergraduate type thesis and his doctoral thesis, they both have the word bentonite in there. So I think he's kind of started on that route of bentonite very early in his career, and I know he's kind of continued that. And then since 2002, I believe, Stephan's been at the BGR, so over 20 years, but had a little spell in industry as well. He's the recipient of a number of esteemed awards from the German, the Deutsche Ton and Ton Mineral Group, I believe, and also, as I mentioned earlier, the George Brown. So without any further ado, we'll kind of get into the questions and see where it leads us. So could you start by telling us, Stephan, how you kind of got into clay science? Who influenced your career path? Where was the kind of start for you?
Well, I studied mineralogy, really classical mineralogy, like with deposits and with light microscopy section investigation.
Right.
So what you do in such institutes is you're dealing with ore minerals, like with copper, with gold, of course, and that was also the focus of the institute I was studying.
Okay.
My first, let's say, something like a pre-thesis that we had to do was about copper ore from German deposit, right?
Okay.
That was, of course, where my focus was on. But then I realized that when you would really like to work on ore minerals later on, then you would have to go to Africa. You wouldn't have the chance to do that in Germany, right? Because there is no really an ore industry anymore. And then I got the chance. I was asked to do a study on bentonite, and it's actually now 30 years ago, exactly 30 years ago, that I first entered a bentonite mine. It was one of those in Bavaria, and where we started to investigate the bentonites and had the idea to improve the quality control, actually, because at that time quality control was more or less like in the mine, you just tasted it with your tongue and said, well, that's a B2 quality, and that's could be a G3, like this. And, at that times, we had to really revisit our quality management, because it was really, we had to document more. And this kind of quality control, of course, could not go on anymore. So that was the idea to find a method where you in the mine could directly have a pre-classification of bentonites, right?
Okay.
And when I started this first time visiting the mines and talking with those experienced bentonite guys, I realized that they couldn't hardly answer my questions. So they knew a lot about bentonite, but those questions I had about bentonite, they could not answer them. And that was the point where I realized that it's probably a good discipline to work on, because nobody knows how it works.
Okay.
Bentonite has so many bears so many open questions, and if you really like to understand the material in a deeper way, then you would have to answer a lot of questions before, which are not answered so far. So that was actually the point where I decided, as long as they can't answer these questions, it would probably be a good idea for me to do that.
Okay. Yeah. And early mentors or any particular people that sort of,
Yeah, Andreas Decker was surely my first mentor from the company S&B Industrial Minerals.
Right.
He was a former student and a doctoral student as well of Aachen, and he came back and he was searching for some young scientist who could do this job, and then we met, right? And yeah, but he was at the time where I started, he was already at the company, so he was
Okay.
responsible for such R&D things and stuff, right? And therefore we met, and yeah, it didn't take long until we recognized and decided that we could work together, and that could be a promising thing.
Okay. Yeah. And it's interesting that you said you kind of started with mineralogy as well, because I see the large quartz crystal just to the side of you there.
Isn't it great? I got that last week, and
Yeah.
somebody wanted to get rid of it, and I said, "Well, if you really want to get rid of it, I mean, you can get some money for that." He said, "No, just take it." I said, "Oh, no problem, I
Yeah.
will."
Yeah. I know when I visited you as well in the past, you have a fantastic collection of clays. So you clearly like going out into the field and getting things and assembling things together, like
The
that.
thing is easy if
Um,
you know we all know that there are so many open parameters, so many different parameters to be considered in the field of clay science, and the only thing to do is then you must have a sample set which is covering all the parameters. Otherwise,
right.
you will never find or never be able to really answer a question based on solid statistics. This is simple mathematics, right?
Yeah. Yeah. So over the years, bentonite's been a key theme for you. I would say that's pretty fair to say, isn't it? Um, and of all the things that you've worked on over these years, what's been the absolute favorite thing that you've really found the most satisfying that you've done in your career so far? Piece of scientific research or laboratory study or something where you've just thought, oh yeah, this is, the most interesting thing I've done, and I'm really happy with how this has turned out.
I would actually mention one study which didn't really take long. It was about perlite.
Okay.
Perlite is in a way related to bentonite, at least in Milos. The deposits are nearby, and production is also performed by the same company. So at that time, we also produced perlite, and yeah, I was asked if we could do some optimization of the production. And then I read quickly into perlite. I mean, the literature is by far not that significant as in case of bentonites or in case of other clays. You don't find so much about perlite. But it was yeah, it took me like 1 year, maybe 1.5 years, until I understood how to optimize this perlite production.
Okay.
And that was really one of the points where I said, well, simply by comparing it with bentonite research, I found that it could be so easy. Sometimes it can be so easy to really come to even unambiguous conclusions. And that was the presence that perlite made me, right?
Yeah. So what is perlite exactly? I mean, I've got a vague idea. It's kind of an amorphous or a semi-amorphous kind of, is it a glass type material or?
You're right. It's volcanic
Yeah.
glass. It's
Yeah.
mostly acidic volcanic glass, right?
Right.
And the big question is where is the water? It's obviously water-containing volcanic
Right.
glass, right?
Okay.
And
Okay.
it has the property, at least this perlite, which is produced industrially, that if you heat it for seconds, I mean, we're talking about 1, 2, or 3 seconds, not more, at 1,000 degree or 900 or 1,100 or something. These are the production parameters, right? If you heat it for a very short time, then it expands heavily, and you have
Right.
a very voluminous, of course, macropores in that case, not in case of as in bentonites, you have more mesopores and micropores. You do have macropores then, of course, and you can use this material as an efficient insulating material, which is not burning, for example, for insulating roofs of houses. It's a perfect material, replacing this fibrous silica stuff, right? It's really successful in this field. So the remaining question is, and there is a discussion between the people from industry working on perlite and the geochemists. The geochemists say that you can only have water inside if there is an alteration. So they assume that it comes from the outside. So it's like a beginning of an alteration, and water enters and you have it somewhere.
Okay.
But as we analyze that by focused ion beam, by infrared microscopy, yeah, with a good
Right.
resolution of about 1 micron, and with SEM as well, we could see that there were some small pores, like 1 to 5 micron. And with infrared spectroscopy, we could easily find that these pores were water-filled.
Okay.
And finally, we found it's quite easy. The water-filled pores are the basis for this expansion. So what happens when you expand? When you quickly heat a silica framework, glass, then it gets soft. You need something which then expands this soft matrix, silicious matrix. And this is usually the water. The water will expand quickly. Yeah?
Right.
But you have to stop this process before the walls break. Because when the walls break, then you have only dust and powder.
Okay.
Right?
Yeah.
There must be, you have to first make the wall very soft. The water expands and you have to heavily stop it closely before the walls would break. And the perfect production point is when the wall thickness is minimum.
Okay.
That's it. But the basis for a good perlite product is the distribution of the water in the glass, which must be primary. Otherwise, it wouldn't be that disseminated. Otherwise, you would have some layers of water or some preferential pathways, and you could never expand the entire structure
The whole
in a
thing.
homogeneous manner. You would not
Right.
do it. And therefore, if you find perlite in geochemically, like from Slovakia, there are some perlites, other places in the world as well. You find glass and water and you name it perlite. But that does not mean that you can come up with a good product from that. You have to investigate the distribution of primary water in this volcanic glass, and then you can decide if it could be a good product for really expansion and for producing such an effective insulating material. So you will find water-containing glasses everywhere in the world. But I guess it was only a very small amount of them can reproduce to such an insulator.
Okay.
Thermal
Yeah.
insulator, right? I'm talking about thermal insulator, of course.
Yeah, that's very. I thought you'd probably say something about bentonite, so it's interesting that you actually went to perlite for the most enjoyable kind of thing you do.
Yeah, and you won't believe it. This study, I think it took me 7 times until it was accepted by a journal. I mean, finally it came up in an online journal from Springer, I don't know. But this is the most read study in the ResearchGate of all my work.
Okay.
So this is probably why that also came into my mind. And it's more easy to explain. I mean, if I would explain the best bentonite study, it would maybe take 2 hours or something.
Yes. Yeah.
So that doesn't take so long.
So moving on to another question. I know kind of clays and rad waste disposal is a big area for the BGR and one that you've been involved in as well. And I think we'll hear some more about that in the George Brown lecture. What for you is the kind of key things happening in that area just now? You maybe heard the other day, for example, that the UK have just given the go ahead for another nuclear reactor to be built. What's going on in Germany with clays and rad waste and things?
Yeah, in Germany we have not taken, we definitely took the decision to not start a new reactor, but instead try to find a solution for the waste we already have, which is quite significant. If we compare that with other countries, we already have a lot of waste to be dealt with. And we are now that we are some years behind the first decision to store it in a salt formation, we are now taking a more careful way. Let's put it like this. We are still negotiating which of the host rocks, of the type of the host rocks would be best. So we are still have not taken a decision if it would be salt formation, which is of course very tight, which has a high thermal conductivity, but which is of course also water soluble. This is a drawback. Or if you would take a clay stone, which is also present in a lot of places in Germany, also in favorable depth present. And we can also, of course, consider the crystalline host rock concept, in which then bentonite, of course, plays a role, as most of us know, right? So this decision was not taken. We have, therefore, to first compare in a more or less quantitative manner, which is difficult, these different concepts before we take this decision. But that means, on the other hand, which is good for the scientists, we have to do research on all of them. So
Okay.
my expertise can be used both in the clay stone, in the clay host rock business, as well in the crystalline host rock research, right?
So what would be the key questions then that concern clay in this overall sphere, do you think, or one or two of them as far as you're concerned?
Yeah, that is a good question. Actually, this is what I'm planning to talk about then in Dublin.
Right. Okay.
Because,
Yeah. Well,
yes.
we don't want to steal your thunder on that one. So if there's any good, things, you can keep those up your sleeve. But if you could tell us something, that would certainly be interesting, I think.
You mean in general of the concerning the
Yeah,
problem?
just in general in clay, the key questions that clay scientists should be looking at if they're working in this area.
Okay, okay. That surely this will be part of the lecture, but it's not that trivial that I would risk that it's not actual that anymore. So it's really an interesting topic. If you consider all the knowledge we have about clay stones, then it is mostly derived from oil industry, gas industry, or it's nowadays from CO2 sequestration, right? This is also a big
Right.
point.
Yeah.
But we have concerning other properties which these industries are not interested in, quite few knowledge. For example, mechanical properties of clay stone, like strength, mechanical strength, or uniaxial strength, as a function of burial depth, for example. There's not much because these industry are not interested in that.
Right.
For a repository, that would be crucial. And I first started when I considered when I tried to compare clay stones, always keeping the burial depth, of course, in mind and the systematics behind that. I first decided that when it comes to swelling capacity, right, that with an increasing burial depth, you would have probably less swelling capacity because you have less smectite, right?
Right. Yep.
But when you think it over and when you look in analogy to the bentonites, you find that the smaller the distance of the particles, which means the higher the compaction, the higher the swelling pressure. And that would mean that probably less smectite, which by compacted on the other way to a higher degree, could exert more swelling pressure than more smectite. And that is a completely open field. You wouldn't find any data. You don't find swelling pressure data as a function of burial depth, and you don't find the free swelling volume, for example, or swelling capacity, let's put it in a more general way, as a function of burial depth. So in that case, concerning this single property, which is important for waste repositories, of course, there are many others, but only considering this one, I would say that the knowledge gap is incredible, and it would be not a problem to come up with systematic studies which will surely find something completely new. So
yeah, that's really
there's
interesting.
a
I think
chance to start a doctoral thesis right now, I would deal
that
with the topic.
that would be the topic. Yeah, yeah.
That
No,
would
it's
be my
interesting what
topic
you
of
say,
choice. Yeah.
because I know the oil industry struggled with this for many years and probably still do in terms of like problem shales. They drill through things and they get a problem and so on, and it's not clear that that's understood
No.
yet. So here with an even bigger issue, radioactive waste. It's really interesting that you say that. I noticed when I had a look at your kind of publications list as well, and you spend a little bit of time in industry, and you had a couple of patents. What do you think have been your sort of influences from the industrial perspective? Having had some time working in the industry and then kind of come back into sort of a more academic research role. What lessons did you kind of take from that that's influenced how you approach things?
I like this question because when I studied, it was definitely my goal to work in industry and be successful in industry, successful in a way that I could establish new products, for example. Because my father actually was a chemist, and he made it to up to more than 170 patents in his life.
Goodness.
Um,
Right. Yeah.
yeah, but it doesn't have the publications, right? So I choose the other way then. Anyhow, but that was really what I also wanted to follow and try to establish or to be able to do as well with bentonite or with chemicals or in combination, with additives or whatever. There are so many options to come to new products or to modify them and to come up with better ones. But then I recognized that in the industry, no one really is interested to answer these basic questions. And there were
Right.
every once in a while there were really good examples for the specialty of bentonite. So you always find, if you have a set of bentonites, you can be sure one of them would perform in a specific application differently from the others. And I
Right.
give a simple example that was actually from England. There was one bentonite which could be used for flocculation in the paper industry without adding any flocculant. It was added, it was dispersed for a while, and then it settled itself.
Right.
No other bentonite did that. And that were these questions which were really fascinating me.
Right. Okay.
Because then
Yeah.
then scientists come, they behave like people in different religions. One say, oh, it must be the mineral composition. Others prefer the grain size distribution. And then there's a third religion. This is the morphology of particles religion, right?
Right.
But none of them can prove who is wrong or who is right.
Yeah.
Quite similar to a religion, right? and therefore, in that times, based on these special behaviors of some bentonites, my wish was really was growing stronger to someday be able to answer these questions.
Right.
Right. And in most of the cases, I really made it after decades to admit that.
Yeah. Yeah. No, that's interesting. As I mentioned earlier on as well, the other thing I noticed when I looked at one of your publications list, I think I got my computer to count the number of instances of bentonites. I think 33 I found in titles of probably in titles of your publications and things. And I know you've got a new book out that I've asked you about before actually when I'd be visiting. I know it's out now on bentonites. I had a quick look at what I could find online about it, and I think 7 chapters. You're an author on every one of those chapters, and I guess they sort of edited the overall volume. So can you tell us a bit about that and the aspect I'd particularly be interested in? Actually, you'll know the famous book by Grimm and Guven,
Oh.
1978, I think, was a development in sedimentology book. Bentonite. I think maybe it was just titled Bentonites. But what I'd be really interested in is what are the key things we know now about bentonites that we maybe didn't know in 1978 when Grimm and Guven put that book together, and what are the things that we still really need to do more work on to try and better understand.
So these were a couple of questions, but
Yeah, so two elements there. Yeah. What's
But the basic motivation behind this book was first also resulting from my time in the industry, because I recognized how much knowledge, empirical knowledge, of course, but how much knowledge and experience about how bentonites perform, how to treat them, how to produce them is available in industry and
right.
will never be read by any scientist.
Okay, doesn't make the transition across. Yeah. Okay.
No,
Yeah.
and
Yeah.
because these people work in the industry, they're not used to writing. They're
Right.
not used to publishing things, right? And I thought it would be a good idea to use my contacts to talk with those people and to let's say summarize their knowledge and to keep it for others, and maybe for students starting with bentonite, they would be maybe interested in seeing how empirical and this work is, and what is already known and what is not known. So my idea was to first to save all this, or at least part of this knowledge I was able, or was sure that my former colleagues had, right? And that is therefore most of the co-authors are from industry actually.
Okay,
And
right. Yeah, interesting.
also concerning production, there's a great chapter from Michael Derschuk, who provided photos from all over the world from bentonite mines, and you can see how different the technological state, the technology is in the different countries, and but still bentonite is mined everywhere in the world. So there are
Right.
also fantastic photos, which are now documented for generations after that, and that was also a motivation. And now I come to the comparison with Grimm and Grüven. I talked to Albert Gilg. It was the first meeting in Illinois, at the CMS meeting. I don't remember when it was, 2016 maybe, something like that. Could it be? So I told him that I would write a book, but I will not consider formation of bentonites because Grimm and Grüven have the focus on how bentonite formed, and there's nothing new. And he
Okay.
was really upset. He said, "Well, we have to write this chapter." And I said, I have no clue about bentonite formation. That is definitely not my field of interest. And he directly decided I will do it. We have to write. We have to revise all these ideas and bring new isotope data and bring new geochemical data inside. And there are so many interesting plots. And since Albert Gilg is really experienced, and I would say the leading isotope specialist in clay science, I said that it's a brilliant idea, but I would never dare that by myself, and I would never have decided that we needed it, because still Grimm and Grüven was for me the basis, right?
Right.
And
Yeah.
there was no, because I don't have the knowledge, there was no need to raise any doubts. So I never went that deep into the topic that I could
Okay.
decide
Yeah.
if I would like to know anything else or not. But Albert was definitely the right one then to summarize all his work and all he knows about formation of bentonites, and he puts that nicely in relation to what was the state of art some decades ago, right?
Yeah. No, that's great. I look forward to reading some of the chapters in the book. I think actually the publisher's been in touch and with the conference, and so I know there'll be a copy for people to have a look through at the conference, which would be great.
Well, that's good. And
Yeah.
one further idea was to that is why I always say that my book has main actors. So it is a scientific book with actors. And the
Okay.
actors are the bentonites. You know? So what I wanted to provide is also basic data, because I myself
Right. Yeah.
sometimes look up, if somebody asks you, what is about arsenic content, for example, in Milos? I don't know. I don't have the data in mind. So I can simply look up the geochemical data of a sample set and say, oh no, there's obviously, at least in the mines that were considered in the study, there's no arsenic. Just an example, right?
Right. Okay.
So
Yeah.
you
Yeah.
can
So like a
easily,
reference.
therefore,
Yeah. Yeah.
I liked to, and that one was one of the intentions, to provide a lot of basic data which can be used for looking up things, or even for some correlations. If you would like to correlate magnesium contents with layer charge, for example, you can do that based
Right.
on this data set. So
Yeah.
therefore, it's important to provide all the geochemical and all the basic data. And actually, I got most of the samples, of course, from the bentonite industry. And bentonite industry normally doesn't want to have the locations published. So
Right.
in a lot of publications, I only wrote down it somewhere from India or somewhere from there, right? So that nobody could follow it. But for this book now, all the exact locations are included. So of these samples, you can correlate this data now with the locations where the
Okay.
samples are from.
Yeah. Fantastic.
Yeah,
Yeah.
I
Yeah.
think, yeah.
Yeah. No, yeah, that's really interesting. Um, So I know from visiting your lab actually as well in Hanover that you love experimenting. You've showed me a few times like things that you set up and so on and so forth. Um, so I guess that's kind of a big part of what you like to do. The sort of lab work and the experiments and so on and so forth. So an additional question here would be if the BGR could give you, you know, unlimited funds. I don't say they will, but
No, they
you know,
won't.
and unlimited resources to do whatever you like. What would you do next?
Buy a Milchbauer spectrometer.
A new what? Sorry,
A
uh,
Milchbauer spectrometer.
Boswell. Okay, okay,
Yeah, that is missing very hard. But I have
okay,
I have a connection. I have a cooperation with a professor from Hanover, but I need the project to have an official cooperation, and this is pending at the moment. So the device or the method I'm missing most at the moment is Mörsbauer actually, because
okay.
you can't really do any reasonable clay research without knowing iron 2 or 3. This is impossible.
Right. Yeah. Okay. Um, so finally, or maybe finally, can you tell us about some of the things you do for relaxation? I know a few of them, but when you're not working on clays, what do you actually like to do?
Yeah, the best for relaxation, of course, is to take a long walk with the dog. That's the best, and that's what I
You
always
you
do
maybe heard
after.
mine barking earlier.
Yours barking.
Yeah,
I'm not allowed.
wanted to go for a walk.
Yeah, if I, yeah, mine is not barking anyway. It's only barking in the dark when somebody is going around the house. Then it barks, but that's not very often.
Yeah,
Commonly,
no.
it's just claiming that he has nothing to eat or he would like to eat more, and that's not barking. That's more like crying or something. I can't explain the sound. It's horrible anyway. So, but after work, going into the forest and taking a long walk, this is of course relaxing. But of course, I guess you also wanted to know what I'm doing then, let's say on the weekend, which is not always relaxing, but it's like something completely different. You could
Sure.
put it like this, yeah, to have your mind somewhere else, to free your mind, and that is of course my music. Yes, I love making music, and I love to be in front of others, and in small bars maybe, and then finally with 70 80 people or something, and then finally sing together. That's really very special, and I feel very glad that I have the chance to experience that, because that's surely not not common, or that's not granted. It's really a
Yeah.
present, something like a present, and I feel blessed that I have the chance to do that.
So will you bring your guitar to Dublin?
Now,
Wait.
so far, I split music, and no, not as you may know, did not really split it. There was once someone who said I should write a song about Bentonite. I said that's impossible, and but she didn't give up and came up with a phrase which really caught my creativity. And yeah, then finally there came a song about Bentonite came up. But this is the only interaction or interplay between music and
Work and music.
yeah,
Yeah.
yeah. And my wife always says, suggests that I once should sing a lecture. And I always tell her, well, that will surely be the last one. If it's the last, and I'm sure that it's the last one I will ever give, then I will do that. That's what I promised her. But it must be the last one.
Right.
Yeah, because
Yeah.
there's so many people who would say, who would then be in a way offended. Maybe they would say that I'm not taking things serious, and many would find it great, maybe, but others not. And therefore, you have to be, I think, a little bit careful that you not exaggerate with that.
Yeah, well, wait, I would love to have a rendition of that song at the conference. I think if you if you feel up for it at some point. Yeah.
I'm still waiting for the magic hook for Hellerside. Yeah.
Yeah. Yeah. Well,
I found my last time walking through the forest, or it was like a week ago or something. I found myself really searching for something like a hook, because I have in mind that you're still waiting for that. Yeah,
yeah, well,
but probably I need
Pete
some help.
Ryan's actually been working on that one. So
Who's,
yeah,
work,
we could have a couple of songs perhaps.
who's working on it?
Pete Ryan,
Yeah,
Peter
great.
Ryan. Yeah.
Okay.
Yeah.
So,
Roll over Kaolin, I think is the yeah.
mhm.
But
That's not
so
bad.
yeah.
There's
So
something with roll, and also roll it must be inside of when it comes to Hellerside, of course.
so is there any question about clay that I should have asked you that I haven't asked you?
Let's see the list. Yeah, now, yeah, we answered that maybe, right? One of the questions that is often asked is what are the big clay questions to be answered?
Yeah. That's I did mean to ask that one actually, and
And
that's
maybe I touched this. I touched the answer to this question by mentioning the three religions. And I personally, I'm a follower of the particle shape, particle morphology religion. So I think that
okay.
is one thing we really need to. We don't have a method for really comprehensive characterization of particle
Shape.
morphologies. We
Right.
have
Yeah.
some efforts like WET-TM. This is a nice attempt, but it's not free of artifacts, of course, and it's hardly representative of the entire sample. So
Hmm.
I think that is would be is one of the key
Something to pursue.
standing. Yeah.
Yeah. Yeah, that's interesting. Yeah. Because I think with lots of different methods for measuring shape as well, you get very different answers, don't you? So
In which
it's kind of
religion
hard
are
to
you?
know. Yeah, exactly. Yeah.
I think you are not in the mineralogy religion because you know always the exact mineralogy. So you must also be in the particle size or particle morphology religion.
Okay. So no, but I think that's great. It's been fantastic speaking to you, Stefan, and giving us some
Thank
insights, I
you.
think, into what kind of drives you in the clay research world. Um, I'm sure everyone will be looking forward to your George Brown lecture, which we're going to open the conference on. Um, it's the 26th, I think, in the George Brown series, which has been going a little while now. Um, and I think you're going to speak about different clay stones and things. That's right, isn't it? In
Yes.
are those all German examples or all kinds?
No, no, the international.
Yeah, okay, fantastic. Yeah, so I'm sure everyone will be looking forward to that. But no, thanks very much for chatting today, and maybe we can have a chat over a beer or something in Dublin, a Guinness perhaps.
Definitely. Oh, I love Guinness. I am looking forward to that and to
Yeah,
the talk as well.